That blue you are looking at is water, oceans covering 71% of the planet's surface. Water in the atmosphere, in the ice caps, in the ground beneath your feet, and inside your own body. Now here is the problem. According to everything we understand about how planets form, none of it should be there. We are here today to explain one of the most fundamental unsolved questions in planetary science. Welcome to the story of Earth's water, the paradox. When Earth formed approximately 4.5 billion years ago, it was not a planet in any sense we would recognize today. It was an extremely hot ball of molten rock, bombarded constantly by debris, with surface temperatures far beyond anything capable of supporting liquid water. Any water present in those early stages would have evaporated immediately and been lost to space. But there is more to it than that. Earth did not just form in hot conditions, it formed on the wrong side of a boundary, the ice line. In the early solar system, there was an invisible boundary called the ice line, sometimes called the frost line. Inside this boundary, where Earth sits, temperatures were too high for water to exist in any form other than vapor. Beyond it, further from the sun, temperatures were cold enough for water to freeze into ice, becoming incorporated into comets, asteroids, and the building blocks of the outer planets. Earth formed entirely inside this boundary, from dry, rocky material. The rocks that built our planet contained almost no water to speak of. So the question is not simply where Earth's water came from. The question is how it got here at all, from a zone of the solar system where water had no business existing. That is the paradox. And it gets more complicated before it gets clearer. The Hadean Eon. The earliest period of Earth's history is called the Hadean Eon, named after Hades, the Greek underworld. The name is earned. The surface was lava. The atmosphere was toxic. There were no oceans, no continents, and certainly no life. Then something significant happened. A body roughly the size of Mars, which scientists have named Theia, collided with the early Earth. The impact was catastrophic enough to vaporize a significant portion of the planet's outer layers and throw enough material into orbit to eventually form the Moon. If any trace of water had somehow survived to that point, this event removed it. Earth, after the Theia impact, started again from nothing, which makes the oceans that came later all the more difficult to account for. The Late Heavy Bombardment. Around 3.9 billion years ago, Earth went through a period known as the Late Heavy Bombardment. For reasons that scientists are still working to fully understand, the inner solar system was flooded with asteroids and comets from the outer regions, and Earth took an enormous number of impacts over a relatively short geological period. For a long time, comets were the leading candidate for delivering Earth's water. They are, after all, essentially dirty snowballs, rocks coated in ice, traveling in from the cold outer regions of the solar system, exactly where water was available in abundance. The logic was clean, the timing worked, the comets arrived, and the water came with them. But then we actually analyzed the comets and the story became more complicated. When the European Space Agency's Rosetta mission reached Comet 67P in 2014 and measured the chemical signature of its water, the results did not match. The ratio of hydrogen isotopes in comet water is measurably different from the ratio found in Earth's oceans. The comets, it seems, were not the primary source after all, or at least not the whole answer. Two theories, both still standing. So where did Earth's water actually come from? The honest answer is that we do not know for certain, but there are two serious scientific theories, and neither has been ruled out. The first is the asteroid theory. A class of asteroids called carbonaceous chondrites contain hydrated minerals, meaning water is chemically bound within the rock structure itself rather than sitting on the surface as ice. When these asteroids struck Earth during the Late Heavy Bombardment, the energy of impact released that water as vapor, which eventually accumulated in the atmosphere and condensed into the oceans. Isotopic analysis of carbonaceous chondrites shows a much closer match to Earth's ocean water than comets do. This is currently the leading external source hypothesis. The second theory is that the water was already here, not on the surface, but locked inside the planet itself. A more recent body of research suggests that the materials that formed Earth may have contained water trapped deep in their mineral structures, and that this water was gradually released over billions of years through volcanic degassing, the process by which gases escape from the mantle through volcanic activity. The discovery of a mineral called ringwoodite in a diamond brought up from deep within the mantle added significant weight to this idea. Ringwoodite can store water within its crystal structure, and the sample retrieved contained clear evidence of hydration. Extrapolating from that single sample, some scientists have estimated that the mantle may contain more water than all of Earth's surface oceans combined. Both theories are supported by evidence. Both are consistent with what we know. And most scientists today believe the real answer involves some combination of the two, though in what proportion remains genuinely unresolved. The oceans form. However, the water arrived, and at some point, Earth cooled enough for it to stay. Water vapor that had accumulated in the atmosphere began to condense, and what followed was a period of rainfall on a scale that has no modern equivalent. It may have lasted thousands of years. It may have lasted millions. The rain filled the low-lying basins of the surface, and the first oceans formed. That early Earth was almost entirely covered in water, with very little dry land visible above the surface. The oceans dissolved minerals from the rocks beneath them and became salt water. And in that salt water, in conditions we are still working to fully understand, something else began: water and life. Water is not simply a habitat for life. It is the medium through which the chemistry of life becomes possible. It dissolves molecules. It facilitates the chemical reactions that drive biological processes. It stabilizes the structures of DNA and proteins in ways that no other known substance can replicate. The first forms of life on Earth most likely appeared near hydrothermal vents on the ocean floor, where superheated water rich in minerals provided both the energy and the raw materials for the earliest biological chemistry. The ocean was not just the place where life began. In a very real sense, it was the reason life was able to begin at all. Water also has physical properties that are, when you examine them closely, almost suspiciously well-suited to maintaining a living planet. It remains liquid across a wider temperature range than almost any comparable substance. Ice floats rather than sinking, which means frozen oceans form a surface layer that insulates the liquid water below rather than freezing the entire ocean solid. And water has an exceptionally high capacity to absorb and retain heat, which is a significant part of why Earth's climate is as stable as it is. Without those properties, the planet we are looking at from the moon would be a very different place, probably not a blue one. We are an extension of it. The water cycle on Earth is not a background process. It is one of the central mechanisms by which this planet maintains the conditions for life. Water circulates between the oceans, the atmosphere, and the mantle. It is recycled by tectonic plates over geological timescales. A small amount is gradually lost to space. The cycle has been running in some form for nearly 4 billion years. The water you drink today is not new. It has moved through oceans, through ice ages, through the bodies of organisms that lived and died long before anything resembling a human being existed on this planet. It has been rain and ice and ocean and vapor over and over for billions of years. The human body is roughly 60% water. That water carries the same chemical signature as the primordial oceans. We did not arrive on a planet that happened to have water. We are, in a very direct biological sense, made of it. To close, the origin of Earth's water remains a partially solved mystery, and we hope that alone tells you something about how much is still left to learn. What we do know is this: whether the water came from asteroids, from the mantle, or from some combination of both, it transformed a hellish ball of molten rock into the only planet in the known universe with oceans on its surface. Earth does not merely have water, it is defined by it. And so, it turns out, are we.